First of all, I want to talk about the decimal numbers that you are familiar with them. Decimal numbers means that we are talking about the normal numbers that we have learned up to now during our school with the base of 10. For example, if we have this number, we can rewrite this number like that. 759. Then we can rewrite this number like that. 7 times 10 to the power of 2 means 100 plus 5 times 10 to the power of 1 means 10 plus 9 times 10 to the power of 0. Each number to the power of 0 is equal to 1. It means that we have 9 times 1. As you see, from the right up to the left of number, we increase the value of power of base of number. It means that this number, this digit is base, is our base. We want, because we wanted to write the number in the decimal system, we write here this base 10 and started the power of this base from 0 up to the end of the number. Similarly, we can rewrite and represent all of the numbers in the different numbering system. For the fraction part of the system, again, we can write the same thing. For example, 200, I don't know, 41.63. Again, for this number, we have to divide the number into the integer part and the fraction part. For the integer part, similarly, we start from the right side with the power of 0 and go through the number. It means that we will have 0, 1, 2. What does it mean? It means that I can write 2 times 10 to the power of 2 plus 4 times 10 to the power of 1 plus 1 times 10 to the power of 0 plus, for the fraction part of the system, I have to start with the negative power of 10 and start with the minus. Similarly, for the all of the numbers in the decimal system, we can write this form of numbers. But generally, we can say that if we have a number like that, an minus 1 up to a 1 0 in the base of B, we can rewrite this number like that. An, this is the coefficient of number, this one. An is this one, An minus is this one, An minus 2 is this one, and so on. And again, and also we can add the fraction part, a minus 1, a minus 2, up to a minus n minus 1, a minus n. This is similarly is like this number. I can rewrite it like that, an times b to the power of n plus a n minus 1 times b to the power of n minus 1 up to the a1 b1 plus a0 b0 plus a minus 1 times b minus 1 up to the end. What does it mean? What I am saying, suppose that we have in the decimal number with the n, with the b, n. In decimal number, how many numbers do we need to write the numbers in the digital number? How many digits do we need? Start from 0, 1, 2, 3, 4, 5, 8, up to 9. For decimal number, we can represent a number in decimal system with using these digits. For the system in the base of 8, what about this one? According to this system, generally we can say that we can represent this number like that. If b is 10, it means that the last number is 10 minus 1, 9. For the b8, what about 0, 1, 2, up to 7? For the b2, 0, 2 minus 1, 1. For this reason, this is called binary system. This is called octal system. The number that are in the base of 8 is called octal. The number that is in the base of 2 is binary system. Now, what about if our b is 16? According to this phrase, I can say that for representing a number in the base of 16, which is called hexadecimal, we can write the number using these digits: 9, 10, 11, 12, 16, 14, and 15. Why? Because b is 16, 16 minus 1 is 15. Using these digits, we can represent each number in hexadecimal. Please notice to this matter. But in the case of hexadecimal, up to here, from 0 up to 9, we represent these numbers, which is come from the base decimal number. But for the A, we used A, capital A. For 11, we use B. For the 12, we use C. For the 13, we use D. For the 14, we use E. And for the 15, we use F. What does it mean? It means that if you have a number like that, 4, B, C, 5, it means that this number is in the base of 16. We need to represent all of the numbers inside of the parentheses with writing the base of the number in the subscript of the parentheses. Let's give an example about these numbers. Let's talk about the number in the binary system. In the binary system, we said that we only use 0 and 1. Suppose that we have this number 11010.11. Always we have to write the base of the number. If you don't write the base of the number, it can be wrong. Why? Because this number can be represented also in the decimal, octal, in the decimal, in the hexadecimal. This number is acceptable for all of the systems. But if you want to represent that, what is the meaning of this number, you have to represent the base of the number. Okay, according to this formula, we can rewrite this number like that. Look at here. I said that before the fraction, this is the integer part of the number, and this is the fraction part of the number. For the integer part, we start the powers of base with 0, 2, 3, 4. And for the fraction part, we started by minus. Okay, I can rewrite it 1 times power base, to the power 4 plus this 1 times 2 power of 3 plus 0 times 2 power of 2 plus 1 times 2 power of 1 plus 0 times 2 power of 0 plus 1 times 2 power of minus 1 plus 1 times 2 power of minus 2. Now, what is this number? To the power of 2 plus to the power of 3 times 1, 8. plus 2 to the power of 2
4
times 0
0
0
plus 2 to the power of 1 2 times 2 2 times 1 2 plus 2 to the power of 0 0 times 0 0 plus to the power of minus 1, it means that 1 divided by
1
2
divided 2
and also
1
1
divided 4
4. And if 1 divided 2 plus 1 divided 4, if you add all of these numbers, you can find that the value is 26.75. This is in the base of 10. You could convert the number in the base of 2 to the number in the base of 10. Also, suppose that we have this number 127.4 in the base of 8. Please notice to this matter, you cannot read this number which is in the base of 8 using 127. We can say that again, start from 0, 1, 2, and this is minus 1. So 1 times 8 to the power of 2 plus 2 times 8 to the power of 1 plus 7 times 8 to the power of 0 plus 4 times 8 to the power of minus 1, which is equal to 87.5 in the base of 10. And also for this number B 6, 5, F in the base of 16. If you calculate this number, you can find that the number in the decimal is 46,685, if I'm not mistaken. This is like that. Let's continue. As you see, I've written all of these information that I talked in the whiteboard. I gave an example and talked about the decimal digits and the binary numbers, and I gave an example here. Again, I talked about that. For example, this number can be written like that. This is the general form of writing a number in the decimal system. And again, for the binary numbers and also general information about the base and radix, these numbers is called base or also radix, which is used for the decimal number. And the binary number 2 is the radix or base for the also octal number system. We can use 0, 1, 2, 3, 4, 5, 6, 7 for the base of 8, and this is an example. Note that the digits 8 and 9 cannot appear at the octal number, and also in the case of hexadecimal number system, I have written here the letters A, B, C, D, E, and F are used for the digits 10, 11, 12, 13, 14, and 15, and I gave an example for you about the hexadecimal number. And let's look at here. This terminology can be, I hope that is familiar with you. You know about the meaning of KB, which is called the kilobyte, MB, megabyte, GB, gigabyte, TB, terabyte, petabyte, exabyte, and zettabyte. What does it mean? Kilobyte is 10 to the power of 3, mega 10 to the power of 6, giga 10 to the power of 9, theta 10 to the power of 12, and so on. The most important thing is that the computer capacity and the digital systems is given in byte. But we learned about the bit. As you see here, we said that a binary digit called a bit, it means that this 0 and this 1, each of them are the bit. But what about the byte? We say that, please learn this matter. A byte, look at here, a byte is equal to 8 bits. 8 bits with together is byte. This is the difference between the bit and byte. If you see megabyte, it means that you have 1 million bytes. It means that you have to multiply this number to the 8 to represent the number in the bit. For example, a computer hard disk with 4 gigabytes, it means that approximately 4 billion bytes. 4 billion bytes.